Hi, welcome to Chapter 2 for CIS113. This chapter is going to get into designing a program, and what this is going to do is we're going to allow us to learn how to use this thing called Raptor. Raptor is a great flow charting tool. The great thing about Raptor is it actually runs. You can actually hit a run button and it actually executes just like a program would. So when we first get into, in a real world situation, when I first became a programmer at the company I work for, one of the first things we have to do is we have to learn how the life cycle of a program. When does a program get born? When does it basically get its diaper changed? When does it die? And so we basically have to look at all the documentation and look at all the different aspects and their users and where it runs, what environments, all that kind of stuff. We have to know all that. But the basics for programming is the first thing we do is we design the program. We then write the code. We correct any syntax errors. We test the code. Now this is the biggest part right here, is testing. And then if there's any bugs we find, we debug it. And then we would basically put it back into production. And then let's say down the road we need to make a change to that program. We pull it out. We design our changes. We write the code for those changes. We correct any syntax errors. And again, we go into that complete life cycle round and round and round. So we have to first design the program. Now designing the program, the first thing you need to do is you need to sit down with your users and figure out what task are we trying to accomplish? What are we trying to accomplish here? What is the outcome of this program that needs to happen? And so we have to really truly understand what they need. Okay. So here's an example. We have to pour, so this is just an example. We have to pour the desired amount of water into a pot. We have to put that pot on the stove burner. We have to turn the burner on high. We have to watch the water until we see large bubbles rapidly rising. When this happens, the water is boiling. So it looks like we're trying to get water to boil. Okay, so that is the tasks that we have to do to make this happen. Now we may have worked with our users, or we maybe have looked this type of information up to figure out what is going on in that particular situation, okay, to get a better understanding of what needs to happen. Now where I work, there's a lot of programs that I maintained that I knew nothing about what they were basically displaying. I work for an insurance company, so we had a lot of high wind and hail and all of these different numbers and factual things that we supplied to the government. I didn't know what they meant. But my task was to bring this data in, do these specific calculations, display them in a report that we could then mail to a governing body. What that data was didn't make any sense to me, and it didn't have to. All I had to do was provide that data. The data itself, I don't have to understand. But to create that data, I have to understand the creation of that data. That I do understand. Okay, so once I kind of get that, I understand the steps that need to be taken place, then I write down pseudocode, English words. In this case, I'll display, enter the number of hours the employee worked. I input those hours. Okay, so hours is now what's called a variable. It's a container that's going to hold this number of hours worked. Okay, I'm going to then display, enter the employee's hourly pay rate, and then I'm going to get that pay rate from somewhere. Okay, then I'm going to say set the gross pay. So I got another variable called gross pay, and it's equal to whatever we typed in for hours and pay rate multiplied together. We put that information into gross pay. Then I display the employee's gross pay is gross pay. Now that's just basic English way to work through our logic. Okay. Another way we can do this is through flow charting. Instead of the English words, we now have boxes and things that represent specific pieces and parts. So I have this parallelogram, which is an output. A parallelogram stands for input and output. So I display on output on the screen, enter the number of hours worked the employee worked. And then I've got another parallelogram that says input the hours. So get whatever they type in and put it in this variable called hours. Then I display another output, enter the employee's hourly pay rate, and input the pay rate. So again, I have to do that on each specific item. Now notice this is a square box. Now this is what's done on the computer behind the scenes. The user doesn't see this. We set gross pay equal to hours times pay rate. Then I display the output. The employee's gross pay is gross pay. Now, back when I went to college, I'm going to basically show an old man here, we had to do this. We had a template that had all of these different symbols on there, all these different flowcharting symbols. We had a pencil. We had one of those big, long, it looks like a pencil eraser. Our instructor, the very first class I took, he said, make sure you get an ever-sharp pencil and a lot of lead, and buy at least 2 of those long erasers because you're going to be using the heck out of them. And by gosh, he was certainly correct there. So think about creating this flow chart, and you basically go through it. It's called desk checking, where you go through and you become the computer and you go through this thing. Oh, made a mistake. Erase, 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 erase. You might have to erase a whole third of it and then restart over. Okay? Because you can't, because the instructor didn't want, a line out here and a fix and then come back. He wanted it looking like it should. So today we've got great flow charting tools like this program called Raptor. Now, if we needed to, again, this is on paper only. If I needed to have if I was going down one side of the page and I needed to go to the other side of the page, I could use this, what's called a connector symbol. It's just a round circle with a letter, a number, some kind of indicator to show where to go to pick it up again. So I stop here at A, I come over here at A and continue on. If it's on 2 separate pages, I'm going to use this page connector. It looks like a home plate of a baseball game. And a 2 says go to page 2. And this 1 says this is coming from page 1. Okay, so that's a possibility as well. So let's talk about output, input, and variables. So I've got multiply hours worked by, let's talk about input. Input is hours worked, hourly pay rate. The process is multiply hours worked by hourly pay rate. The output is gross pay. Now, I just want to touch on this, but there's a thing called IPO charts, and it's called input processing output charts. And it basically is just, it could most likely just be an index card. And it's got 3 lines. Left-hand side is input, middle is processing, the other side is output. And so here it is, IPO chart for the pay calculating program. Here's input, number of hours worked, hourly pay rate. Processing, multiply the number of hours worked by the hourly pay rate. The result is the gross pay. Output, we're going to display the gross pay. Okay. To display on the screen, we say display. Okay. So here's program 2.1. Our very first program that we're going to look at in Raptor. We just now, let's do this instead. Let's just create this as a brand new program. So I'm going to display K. Austin, display 123 Walnut Street, display Asheville, North Carolina, and the zip code. So this is all output. Since this is output, see this output symbol right here? I click, notice it turns red, and I just click on this little line in between start and end. Okay, we're going to call this. It wants me to save it first. It's okay. So it puts this symbol right there. I double click on it. Now, in order for Raptor, in order to display just text, I have to put double quotes around it. So I put double quote, Kate Austin, ending double quote. Display. So now, Since this is still highlighted red, I can click right here on the little arrow below that, and it puts another output box. I double click. I'm going to put double quote 1234 Walnut Street, ending double quote. Since that's still highlighted, I'm going to click right here to add another output box. Then I'm going to put double quote Asheville, NC 28899, 28899, ending double quote, and I'm done. Now here's what's really cool. I can come right up here to this button of the triangle. That's the play button. Execute to completion. Click on it, and it just spits it out here in the output box. It's displayed Kate Austin, 123 Walnut Street, Asheville, North Carolina, 28899. So pretty cool. That's as simple as it gets. Again, here's that same flow chart. Output, output, output. Start, end. Notice that our, we got start and end as well. And notice up here it defaults to a main tab, and we'll talk more about that in the next chapter. But just realize that this is a module or a procedure by itself. And again, we'll get more on that in chapter 3. So, sequence structures. Now, again, what we just did was a sequence structure. It just went boom, 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 hit the end, and went on. Okay? So that's just linear sequence is all that is. So let's talk about variables and input. So let's take a look at program 2.2. So here, now look at this guy. Well, let's do this instead. Let's go ahead and create this from beginning. So the very first thing it wants is display your age. Now, since that says display and it's asking for input, it looks like we're going to display an output and then get input, and that's not what we're doing here. In a pseudocode or flowcharting world we would, but in a Raptor we aren't. The great thing about Raptor is this. I'm going to grab an input. So I'm going to click input here. I'm going to click. Now so the arrow's coming in. When I double click on it, it allows me to enter a prompt, which is the what is your age. So I put double quote, what is your age, in the double quote, and we're going to put in a variable called age. Now, what is a variable? A variable is a container. It holds data. That's all it does. So in this case, it's going to hold something. In this case, it's going to be the age of someone. Okay? So right now, age has nothing in it. Has absolutely nothing in it. So now what I'm going to do is I'm going to click on output. I'm going to put that right after that, double click, and it says, here is the value you entered, colon, display age. Again, we can do that all in one item in Raptor. I put double quote. Here is the value that you entered, colon, and a double quote. Now, in Raptor, we have this thing called glue. The correct term for it is called concatenation. It allows us to glue pieces together. So in this case, I've got this thing called here is the value you entered, and I want to glue onto that the age. The glue we use is a plus symbol. Raptor considers that plus symbol a plus symbol if it's numbers, but if it's a string and a number or a string and a string, it's called a concatenation symbol. So I type in a plus sign and the word age. Okay. Now here's what's kind of nice about this. If I type in a plus sign, if I type in the letter A, notice some things pop down below there. If I type in a G, Just the age is there. Now again, I could do this back at the A. I could move my arrow key up and down. Once I get the variable I want, I just hit the enter key and it grabs that variable. I'm done. Okay? So now I run this. It says, what is your age? So there's the input. So I type in 24. I hit OK, and it displays, here's the value that you entered, colon 24. Now the one thing that you really need to kind of look at, and I get in this, I think in chapter 2-3. Yeah. Notice that when I typed in, here's the value that you entered, colon, and then I put the ending double quote. And notice that the number 24 is butted right up against that colon. But what if I did this instead? What if I came back into here and I put a space just after the colon and before the double quote? Now it's here is a value that you entered, colon, space, double quote. Watch what happens. I run it again, type in 24. Notice it now looks more appealing because now that 24 is not butted right up against that colon. So it's going to print exactly what you have in your code. If you want a space, you got to basically take care of that space. If you want a slash, if you want a dash, if you want something like that, you have to code for that. So now it says, here's the value that you entered, colon, space, 24. Let's open up 2.4, and here I've got an input. Enter your name. So it's double quote, enter your name, double quote, and it's got a name variable. It says enter your age. So here's another one. Enter your age, and then age variable. So when I get done with those two input boxes, I will have a name and an age. Then I put, look at this, I've got hello space, remember double quotes around it. Here's my concatenation symbol, name, concatenation symbol, double quote, space, you are, space, double quote, concatenation symbol, age, concatenation symbol, double quote, space, years old, period, double quote. So notice how I glued that all together. I glued all those pieces and parts together. Notice I've got spaces where they need to be, or the name would be butted right up against the text, which is what we don't want. So when I run this, I type in Mark, I type in 57, and it says, hello Mark, you are 57 years old. Okay? So how about variable assignments and calculations? So here we want to be able to have some variables and then basically assign a numeric value, in this case, to them. So let's take a look at program 2.5. So here I've got a variable dollars. Now notice it's in a square box. Okay, this is what it looks like. I just set this variable dollars to 2.75. Okay, so I actually use this symbol up here called assignment, and basically that's what that is. Then I used output. I say I have $, double quote, concatenation symbol, dollars, concatenation symbol, double quote, space, in my account. Okay, notice I actually put a $sign in there to basically put in front of that money. So now when I run this, it says I have 2.7500 in my account. Now understand The default decimal places for Raptor is 4. Okay. In another chapter, we will discuss formatting numeric values. But for now, realize it's going to be 4 decimal places, and basically we'll have to deal with that for right now. Okay, so not a big deal. We take a look at 2.6. And again, we basically put dollars. We set dollars at 2.75. We then have, I have that many dollars in my account. Then I change dollars to 99.95, but now I have this many dollars in my account. So I can modify a value of a variable anytime. That's the great thing about variables, is they stand up to their name. They are variable. Meaning I can change it to 2.75, I can change it to 99.95, and I can keep changing it. So when I run this guy, I have 2.75 in my account. Now I have 99.95 in my account. Again, this is what the flowchart looks like. I've got a box where I just set a variable. Remember, boxes are those things that are done behind the scenes. Those are done on the computer. That's done inside the program. Where they just display the outputs and the inputs, those are what the user sees. So we talk about calculations. Now, we saw the plus sign earlier. There's a concatenation symbol. When you use a plus sign with a string, it's concatenation. When you use it with numerics, it's addition. A dash is subtraction, an asterisk is multiplication, a forward slash is division, and mod, that is division, but what you get back is the remainder. Okay? So if I say 6 mod 4, I'm taking 6 and dividing by 4, and what's going to be returned is the remainder. And then an upside down V, or what's called a caret symbol, is an exponent. So if I said 3 caret symbol 4, that's 3 to the 4th power. Let's take a look at program 2.7. So here I've got a variable called price. I set it to 100. I create a variable called discount. I set it to 20. I create a variable called sale, and it's going to be equal to, so let's see what that looks like. So here's sale, and it's equal to price minus discount. Okay? So it's taking price and subtracting discount and putting it into sale. And then I display the total cost is sale. So the only thing the user is going to see is this last one, because these first 3 are done behind the scenes. So again, when I run it, the total cost is $80. So in the Spotlight, these are great little kind of declarative textual, hey, here's a situation we need to fix. You need to write a program to do that. So it says, suppose your cell phone calling plan allows you to do 700 minutes per month. You use more than its limit in a month. You're charged an overage fee of 35 cents for each excess minute. Your phone shows the number of excess minutes that you have used in the current month, but it does not show how much your overage fee currently is. Until now, you've been doing the math the old-fashioned way, pencil and paper or calculator, but you would like to design a program that will simply simplify the task. You would like to be able to enter the number of excess minutes and have the program perform the calculation for you. So here's the algorithm. You get the number of excess minutes that you've used. You then multiply that by 0.35, then you display the overage fee on the screen. Okay? So it says you ask the following questions about this algorithm. Question: what input do I need to perform this algorithm? Answer: you need the excess minutes. Next question: what must I do with the input? Answer: I must multiply. Okay, so it kind of steps you through what you need to do. So here's what we're going to do. So here is our program. So the first thing we do is we've got an input box. Inside that input box we say, enter the number of excess minutes. Notice it's got double quotes around it. I create a variable called excess minutes. that now holds a numeric value that I type in. I then have a assignment box. Again, this is done behind the scenes. I say that overage fee, so I'm creating a variable called overage fee, and it's equal to this excess minutes times 0.35. I then display your current overage fee is $, and I concatenate the overage fee at the end of that string. So now when I run it, it says enter the excess minutes. I went 50 minutes over. I now owe my overage fee is $17.50. Okay. And there's a nice flow chart for that. So here's another in the spotlight. So determine the percentage is a common calculation in computer programming. In mathematics, a percent symbol is used to indicate a percentage, but most programming languages don't use a percent symbol for this purpose. In a program, usually you have to convert a percentage to a decimal number. For example, 50% would be written as 0.5 and 2% would be written as 0.02. So we need to get the original price of an item. Calculate 20% of the original price. This is the amount of the discount. Subtract the discount from the original price. This is the sale price. Display the sale price. So if we look here, I've got, now let's dissect this. So I've got the original price, that's one variable. I've got to get the amount of the discount, that's another variable. Then I take that original price and I subtract the discount from it, that is the sale price. That's another variable, sale price, and then I display the sale price. So I've got price, discount, sale price. I've got three variables. Okay. So, enter the original price, I get the original price. I say discount, notice this is a square box, discount is equal to the original price times 0.2, 20%. The sale price is equal to the original price minus the discount. Then I display the sale price is $, and I concatenate on sale price. So original price, discount, and sale price. There's my three variables. Okay. Two of those items are done behind the scenes. There's my input, my output. So I run it. The original price is $58, and the sale price is $46.40. Talk about the order of operations. Very, very important that we understand the order of operations. We do anything inside of parentheses first. We do any exponents then. Then we do any multiplication or division, whichever comes first. Then we go back to the beginning. We then do any addition or subtraction, whichever comes first. Okay. So in this particular situation, I've got 12 plus 6 divided by 3. Well, again, any parentheses? No. Any exponents? No. Any multiplication or division? There's 6 divided by 3. 6 divided by 3 is 2. Then I go back to the beginning, and 12 plus 2 is 14, so that is 14. Okay. You can kind of step through these and kind of go through and see what these on your own. But realize the order of operation. This is probably, if you've taken any math in the past, you should know about that. So here is another in the spotlight. Determine the average of a group of values in a simple calculation. You add all the values and then divide by the sum of the number of the values. Although this is a straightforward calculation, it is easy to make mistakes when writing a program that calculates an average. For example, let's assume the variables a, b, and c each hold a value, and we want to calculate the average of those values. If we are careless, we might write a statement such as the following: a plus b plus c divided by 3. What's going to happen there first is the c divided by 3 is going to happen first, and then it's going to add them together. That's not what we want. So instead, we are going to put parentheses around the a plus b plus a c, and then the divide 3 is on the outside of that. Okay? So We look at program 310. So we're going to get a test score 1. We're going to get a test score 2 from the user, a test score 3 from the user. In my assignment box, I say the average is equal to, notice the parentheses around test 1 plus test 2 plus test 3. Outside of that parentheses is divided by 3. And then I say the average score is concatenation symbol average. So input, input, input. Those will be displayed to get those 3 variables. I will then do my calculation and then display the average. So it's 90, 80, and 70. The average is 80. So again, I knew that I picked the easy numbers so we could show a good average. Advanced arithmetic operators, exponent and modulus. Okay, so I could say the area is equal to the length exponent 2, or length squared. Or I could say the leftover is equal 17 mod 3, so 17 divided by 3. What the remainder is going to be is put into leftover. Okay. This gets into some kind of the algebraic expressions. So 6b is 6 times b. If I have 3 parentheses around 3 and parentheses around 12, that's 3 times 12. And 4xy, that's 4 times x times y. Okay, and that is x equals a plus b divided by c. So we're going to do a plus b first and then divide by c last. Okay, so here's our spotlight. Suppose you want to deposit a certain amount of money into a savings account and leave it alone to draw the interest for the next 10 years. At the end of 10 years, you would like to have $10,000 in the account. How much would you need to deposit? So this is what is called present value. What that says is I know what I want, so I want to deposit some money into a savings account. I know what the future value is. I know what I want that to be. And I know what the interest rate is. I know how long I'm going to keep it in there. How much do I need to deposit into my account to get to that future value? Okay? So the present value is equal to the future value divided by 1 plus the rate exponent or raised to the power of the number of years. Okay? So we have 1, 2, 3, 4 variables we need to get, or we have 3 variables we need to get from our user, and then we are going to calculate the 4th variable. Okay? So we take a look at 211. It says, enter the desired future value. We're going to then get, so again, that's just an input box. We put in double quotes, enter the desired future value, double quote, and we're going to put that in a variable called future value. Enter the annual interest rate. We get the rate. How many years will you let the money grow? We get years. Now, here's our calculation, our assignment. Our present value is equal to the future value divided by parentheses 1 plus rate raised to the number of years. Then we will display, you will need to deposit the present value. Okay? That's an output box. See the out going out, arrow going in, arrow going out. Okay. Desired value, $5,000. Interest rate is 0.05%, so it's basically 5%. I'm going to let the money grow for 6 years. It says you will need to deposit $3,731.08, be rounded to 8 cents, into your account today, and in 6 years that will grow to $5,000 at 6% interest. Again, nice flow chart to see Nice way to convert this into what we need to do in Raptor, but realize these two boxes are done in one. Okay, so now, up to this point, we've just created variables willy-nilly. We just created them, just a generic container, going to hold whatever. What we're going to do now, though, is we're going to talk about declaring a variable. Now, we really can't declare a variable in Raptor. We kind of sort of can, but we're going to take it a step further, and we're going to use some comments to basically let people know what this data type should be. Because realize, here's what we're doing. This class is designed to create flowcharts or pseudocode to work our logic for our program. Then we take this pseudocode or flowchart and give it to the programmer, and they're going to write the program from it. Okay? So when they see the data type and a comment of a Raptor program, it will basically notify the programmer on what data type they should declare that variable at. When we get to the chapter we start talking about OO, I will show you how Raptor can actually create Java code for us. It's pretty cool. Okay, so in pseudocode or most languages, we will say declare integer. Now, an integer data type is a numeric value with no decimal places. It's a whole number. The variable name is length. Declare real gross pay. A real data type is a numeric value that has decimal places. So those are the only two decimal places we're going to use in this class. In programming, in a real programming class, we have floats and doubles and integers and shorts and all kinds of different variable numeric types that we can declare them as. And that's so again, I talked about the variable being a container. Okay? It's a Tupperware bowl. When I declare that length as an integer, here I've got this Tupperware bowl. It's got the name length on the outside. And it also says integer. It says the name of this bowl is length. The only thing that can go inside of it are integers. That's it, nothing else. If you try to put anything else, it could cause an error. Gross pay is another Tupperware bowl. It's got gross pay on the outside. That's the name of this bowl. It also has the word real next to it. It says the only data that can go into this bowl is real data type. Okay. I can also declare on one line 3 variables as an integer. I say declare integer, length, comma, width, comma, height. I just declared 3 variables. They're all integer data types. So 3 separate bowls. I got a length bowl, a width bowl, and a height bowl. They all got length, width, and height now on the outside. And integer, meaning the only thing I can put in there are integer data types. So let's take a look at program 212. And notice I've just created this variable age willy-nilly. What is your age? Age. Okay. Now, right now I can put anything in age. I can type text. I can type anything in there. I can type an integer. I can type a real. It doesn't matter. So I could type anything you want. So what we need to do, though, is we need to declare variables first. Okay? So okay, so this has done it wrong. So let me do it correctly. So here's what I'm going to do. I'm going to create a variable. So I'm going to come up here. I'm going to click the assignment box. I'm going to click on this arrow just after start. I double click in there. I'm going to create test1. To make it a real data type, I put 0.0. I have to initialize it to something. I click done. I'm going to put a comment. To put a comment, I do a right click on that box. I say comment. I'm going to put real. Since the assignment box is still selected, I'm going to click below that. Double click. I'm going to type test 2. I'm going to set that to 0.0. Do a right click, comment real. Create a third test variable called test 3. Initialize that to 0.0. And make that a real data type as well. So now, I've declared my variables. I use them down here. I'm going to get rid of these comments. Don't need them. I then get the test score. Get the test score. Get the test score, then I do my average, and then I display it. Okay, so it's not going to run any different. Okay, so 90, 80, and 70, and the average score is 80. So again, it didn't change anything of the program, but whenever we use a variable, we need to declare it first. We need to basically set aside in memory this amount of space, and so since I told it 0.0, Raptor knows that's a real data type, so it's going to reserve this much space for that variable. Okay. Variable initialization, that's what I did in this program, is I declared it and initialized it. I have to do that in Raptor. In programming languages, I do not. Once I declare a variable, I can just declare a variable, and it will actually contain a null value. Numeric literals and data type compatibility. So a numeric literal is this 2.75. The variable is dollars. Okay, but what if dollars was set as an integer, and I'm trying to put 2.75 inside of there? Well, guess what's going to happen? It's going to truncate off the 0.75 and just bring the 2 in a real programming language. And Raptor will actually allow it. So declare integer I, set I equal to 3.7. Set I, so there's an error. What's going to happen is only 3 is going to be there available. Integer division, if you ever do division, make sure the results are always a real data type. Rarely do you get division of a whole or integer numeric value. Okay, constants. Constants are those values that I want to set at the beginning of my program, and I don't want them to ever change. Now, in Raptor, we don't have that. We don't have that particular allowability for constants, but again, we can kind of fudge it. Now, constants are variables, but they never ever change. Now, in a real programming situation, we would say something like a constant. In Java, we would call it, Java is a final. In VB, it's a const, const. Okay. What that means is we create the variable and we initialize it, and it can never, ever change. Within the program, we cannot go in and try to change that variable. So here I've got interest rate 0.069. Now, one thing I want you to notice is the word interest rate is all uppercase. That, as programmers, whenever I see a variable that's all uppercase, that tells me it's a constant. Okay? So, in this section here, this is where you become the computer. Okay? And so here we've got this box over here, and it says declare real test 1, declare real test 2, declare real test 3, declare real average. Oh, that's one thing I forgot to do over here. Aha! I've got average. I need one more assignment variable, and that is average, and that is 0.0, and that is a real data type. Okay, because there's 4 variables here. Yep. So I declare my 4 variables. Now, normally that's where we do it. We normally declare our variables at the very top, and we utilize them down below. Okay, so declare our variables. Then I set test score 1 to 88.0, set test score to 92.5, set the average, and display our average. We didn't do anything with 3, did we? So basically what we do is we write this stuff down on paper. We become the computer. We work the logic out. So we actually do exactly what the program is telling us to do, or this flowchart or pseudocode. We do that. We basically make sure it works. Back in the day, back slightly before my time, they used what was called punch cards. And you would basically write your program, and then you would then say compile, and it would create all of these punch cards. These punch cards had all these square holes in there. And you might have a stack of cards this tall. You would then give it to the computer operator. They would then load those cards into the computer. It would then load that program and execute it and run it. Now, I've been told it can take anywhere from 2 to 8 hours to compile and run this program from these punch cards. So guess what? You really want to make sure the logic is sound and everything's going to work correctly before you turn those punch cards in. Because if you come back 8 hours later and find out you made a mistake, guess what? You got to go through that whole entire process again. So back then, those folks really sat down, and it's called desk checking. They become the computer, they go through the code, they write everything down, they do the calculations, they do everything as were they were a computer. Making sure that everything is checked, everything basically works before they went and turn that stuff in. Today, we get kind of lazy, and we just basically compile and run our code. I call it the Big Bang Theory. We compile and run our code, it blows up, there's the Big Bang, we fix it, we run it again, it blows up, another bang, okay, we keep doing that until it basically runs correctly. Documented program, we don't have, we can put comments on our code, but we cannot do things like this where we got block comments. We can only put comments. We can do a right click on a particular box in Raptor, right click and type comment and put comments in that way, and that's about all we can do. We cannot put these block comments in there like that. Okay, so here's another in the spotlight using name constants, name style conventions, and comments. So here's what it wants to do. The number of millimeters the ocean will rise in 5 years, 7 years, and 10 years. Okay. The amount of the yearly rise is the amount of yearly rise times number of years. Okay, so let's take a look at program 214. So here I declare a variable called 5 years. I initialize it to 0.0. It's a real data type. 7 years, 0.0, it's a real data type. 10 years, 0.0, real data type. Notice yearly rise, all uppercase. Tells me it's a constant. I initialize it to 1.5. I put in my comments, it's a constant real. I then do a calculation. 5 years is equal to the yearly rise times 5. I then display the ocean levels will rise, concat 5 years, concat millimeters in 5 years. I then do a calculation. 7 years is equal to the yearly rise times 7. I then display the ocean levels will rise, concatenate 7 years, concatenate millimeters in 7 years. Do another calculation, 10 years. Yearly rise times 10. Then I say the ocean levels will rise, concatenate 10 years, concatenate millimeters in 10 years. Then I end. So I run this guy, and it says the ocean levels will rise 7.5 millimeters in 5 years, 10.5 millimeters in 7 years, and 15 millimeters in 10 years. So the whole point of that is the comments are constant variable. Now, even though I've declared that as a constant, again, Raptor doesn't have constants. I could change that variable to something else, but since I have constant in there and I've got all uppercase, a programmer knows when they are programming this particular code to make sure that is a constant variable. Okay, so we're going to design our first program. Yay! So we're going to create a batting average program. Batting average is equal to the number of hits of a baseball player divided by the number of times at bat. Okay? So we're going to get some input, we're going to do some processing, then we're going to display that. So our input is received. To determine our program's input requirements, we must determine the pieces of data that are required for the program to complete the task. Number of hits, number of times at bat. Some process such as calculation is performed on that input. We're going to take the number of hits divided by the number of times at bat. We're going to then display that output. Okay? So let's just take a look at the program. So here is my variable hits. It's set to 0. It's an integer data type. At bats is set to 0. It's an integer data type. Batting average is 0.0. It's a real data type because we're doing division. I then get the number of hits. I display an input box, enter the player's number of hits. I'm going to put that into hits. Enter the player's number of times at bat. I'm going to put that into the variable at bat. Then I'm going to do the calculation. Batting average is equal to hits divided by at bats. Then we're going to display the player's batting average is, concatenate batting average. Run it. Number of hits, 50. Times at bat, 82. The player's batting average is 0.609, so 60, a little over 60%. Okay? Pretty cool. So, okay, so again, as we see, Raptor is a great program because it actually runs the code. We can declare our variables, which we should always declare our variables before we use them. We can't. So in the beginning of this chapter, we were just saying input box get age. Okay, we didn't declare age. Well, we should really declare. We need to declare our variables before we actually use them. We do our calculations in an assignment box. We use input boxes to get input from the user. We display everything in the output box. We can concatenate things in our output box by saying string inside of some text concatenated to a variable name. Okay. Chapter 2, great introduction to flowcharting, great introduction to Raptor. If you have any questions, give me a call, text me, whatever the case may be. We can Skype. Be more than happy to help. We'll see you in Chapter 3.